Cool. Good afternoon, everyone. Thanks for joining us today, and thanks. Sorry for the dramatic entrance here. We're just trying to get more people to get in, So today we're going to talk about continuous delivery and DevOps and robots.
Oh my.
So we're going to dive inside Domain's journey down the yellow brick road of continuous delivery. We basically had the choice between The Wizard of Oz or Alice in Wonderland and going down the rabbit hole. We got this one. Sorry about that. So I'm Fabien Ruffin. I'm Technology Director for the group platforms at Domain. And
I'm Jason Brown. I lead up the ops function at Domain. I've been at Domain for about 2.5 years now. I joined at the start of the project that we're about to talk about.
Cool. So first of all, congratulations, everyone. Your project is finished. You're ready to push it to production. Now, if only you hadn't just missed this release window. Now you're going to have to wait 2 weeks. The release is going to be on a Sunday. And you already had plans for that day. True story. I know we've all heard that. We've all been there. But the thing is, it doesn't have to be that hard. What if I told you that you can deploy your code any day of the week if you feel like it? Any size of release. What if I told you you can deploy many times a day, even if you feel like it? And what if I told you you could deploy on the first day of development of a project? Well, if I told you that, you'd probably think I'm crazy, and well, you'd be right. But with a bit of time and a little bit of effort, we actually got pretty close. So we're going to start by having a look at where we were at before we started this process about 2.5 years ago. So to give you a little bit of context, this is the Domain group. We've got about 15 different brands, but that's the major ones, I'd say. So first of all, we've got domain.com.au, which I'm assuming everyone knows here. If not, Domain is one of the leading property platform important, in Australia. We get a decent amount of traffic. We also have commercial real estate.com.au, which is very, very similar, but for commercial properties. So let's say if you're looking for office space or something like that, well, that's where you would go. Then about a year and a half ago, we acquired Whole Homes here. So they're very similar to Domain, but are focusing on the Canberra market. Then My Desktop, they're a CRM for real estate agents. So for them to manage their inventory, their uploads to all the different platforms, and managing their leads and all these kind of things. Now, we also have Australian Property Monitors and Price Finder. What those guys are doing is that they're gathering a lot of data around property sales in Australia. So I think they've got data going back to early 1980s or something like that. Yeah. So one of their core products is to provide valuation for every single property in Australia. They also provide services such as server profile or market analysis, all these kind of things. So anyway, we've got a lot to look after. But today we're going to focus on Domain and commercial real estate because that's where the story started. Everything else after that is following the same principles. So where were we at when we started? Well, we had about 10 web applications to look after, about 50 odd offline services. So what offline services mean for us, that's console applications running on schedule. So let's say to email you the new properties every morning and all these kind of things, or Windows services. We had two rather large SQL Server clusters, one Elasticsearch cluster to power the search for Domain and commercial real estate. And the deployment of all this was all manual. So as you can imagine, it takes some time. So because of that, we were not able to deploy very often. And our releases were, fortnightly when we're lucky, but more on a monthly cadence really at this point. And more often than not, it would take us a day or more to actually finish a full release. Always very painful. And that's time that devs actively spent doing the deployments. So we decided that life is definitely too short to deploy software or build new servers manually, and things had to change. So we set out with this new project with a set of goals. First, we wanted fast deployments. They also need to be reliable, otherwise what's the point, right? We wanted everything to be keeping manual interventions to a minimum, and the reason for that is so that our teams can focus on spending the time building great new features and delivering that to our customers instead of spending a day fiddling with configuration and making sure that the application is still running. Ambitious goals, but we've got a set of solutions for that as well.
Yeah, noble goals. So we had to come up with some solutions to fulfill them. We decided we were going to go on a microservice platform. You're at NDC, you should probably know what microservices are by now, but small individually deployable units of functionality, loosely coupled. To support this, we knew we were going to have quite a lot of code being pushed out to quite a lot of servers, so we had to put in a full chain integration and delivery platform. We also knew we were going to use up quite a lot of infrastructure, quite a lot of servers. We were really going to only do this with a cloud platform. We couldn't do it in our existing virtualized data center. It was too slow to get new servers. Sometimes we had to wait a full day for one new box. So cloud it was going to be. And to support all this, we were going to have to go with a full DevOps implementation. Now, where's my button's not working, Fabien?
All right.
There we go.
So just to show you where we got to at the end, and before we go to the details of how we got there, this is the Buckle Plotter application. What it does doesn't really matter. What matters is that we used to spend half a day to a day to deploy this, depending on how many times we would stuff up the configuration in the process. When people are involved, people make mistakes. What's important here is that now it takes 46 seconds consistently. And so, yeah, we're not afraid of releasing that thing anymore because, well, we know that it's going to work, second, it's going to be fast, and then we can move on. And this is not the only application we're deploying that way. Just to give you an idea of how crazy it got, this is the number of deployments we do to, release of new code we do to production every week for the first half of this year. As you can see, it's most week it's over 50 deployments to production. And every now and again, we get over 100. And our record is sitting at
around 150.
150, yeah. So yeah, definitely deployment is not the bottleneck anymore. We do a lot of them. And yeah, now the bottleneck is just how fast we can write code, really. But yeah, you know that. So yeah, so let's have a look at how we've done that. So yeah, so we started with some cultural challenges, Tristan, I think.
Yeah, I've got to talk about that, haven't I? Okay.
Yeah, that one.
Thank you. Apologies for the technical problems. All right, so the first cultural challenge we came up against was fear. Obviously, when you're talking about day-long deployments that sometimes fail and you have to roll them back and that can take half a day, there's a lot of fear of change. What if we make it worse? Had to overcome that.
And then we're going to let the machines do it, so imagine that. It's going to get even worse, isn't it?
Machines. We should have gone with like a Matrix theme or something. Anyway, we had to get buy-in from our developers because our developers are the ones delivering this value. They have to kind of believe in this new process that we're doing, otherwise they're not really going to want to do it. We also had to get buy-in from the business. Now I'm sure Fabien's got a disclaimer about this picture.
Yes, so this is in no way representative on how we think about our business. We just had to use the characters. This is it.
And finally, we had to get DevOps in as an actual culture that everybody kind of lived and breathed.
All right, and yeah, you really know that you got to a continuous delivery culture when all of a sudden, out of the blue, you've got people in the team rocking up at work with these stickers on their laptop. Ship it, domain, getting stuff done. This is stuff, right?
Is that stuff? Are you sure that's stuff?
So this is really cool, actually. Every time someone finished something, you could hear, yeah, ship it. And yeah, they were shipping it. And yeah, so at that point we knew that, yeah, we're onto something. But for that, we had to go, like Jason said, in the DevOps world. So what's DevOps?
Yeah, it's that magic word again, isn't it? What's DevOps? Every shop that claims to do DevOps seems to have a different definition of what DevOps is. Every vendor that comes in seems to have a slightly different definition of what DevOps is. If you listen to the big guys like Eugene Kims and these guys that go around getting paid thousands of dollars to appear at conferences, like us obviously, they all say it's the application of Lean or Six Sigma manufacturing processes to the process of delivering software. What is software? Software is a thing we manufacture, we ship it out. If you don't know what Lean or Six Sigma are, they concentrate on things they call the wastes, or the mudas, if you want to be the pretentious Japanese Toyota production system guy. You can probably see some of these wastes in your business right now if you think about it. The talent, if you're underutilized, I mean, you guys are all geniuses, right? Clearly you're underutilized at work, yeah? The ones we kind of focus on a lot are inventory. Inventory is product that is not shipped yet, so code that's feature complete, that isn't in production, that is a waste. That's not making you any money. It's completely wasted. Motion and waiting, they're common things in software too. If you've got to wait on another team for, say, a server, or if you've got to wait on a dependency, maybe that's a waste. And overproduction and overprocessing, you know about things like minimal viable products and minimal lovable products is what we're focusing on these days. So yeah, we want to eliminate as many of these wastes as possible. And defects. None of you produce defects, right? Good, good. We think that's all a bit formal, so we tend to think of DevOps as kind of an applied laziness. Now, what do I mean by that? Ops guys are lazy. We've always been lazy, but we do it in different ways. Back in the first generation, we would put the laziness at kind of the start. We'd not really think in advance and not put the work in to make things easy for ourselves. We'd just log into a box, download a binary, run a binary, move on to the next box. This is terribly boring and awful. Second generation, we decided we were going to write scripts for this kind of thing. So we write a bit of PowerShell, but we still sort of log into the box and run the PowerShell. This is also terribly boring. Maybe we'd use something like SCOM to push that out. Something like that, a tool that would push out the script. Meh, yawn. Third generation is we provide an on-demand service to our developers. So in our case, we write a script, which is just the same script here. We package it up in Octopus deploy, and we tell the devs that it's there. And the devs go, oh, okay, I'll put that in. And we don't have to do anything anymore. It's great. Over to Fabien for the process, I think.
Yeah, so I'm just going to give you an overview of our continuous delivery pipeline very quickly. So first, we put our code in Bitbucket. That's Git. Everyone knows about it now. Then we were using Atlas and Bamboo at the time for our builds, testing, packaging, basically getting everything ready for the deployments. After that, we were shipping all our application packages to a private NuGet gallery. And why NuGet? Well, it's because we're using Octopus deploy for deployment, and that's what Octopus deploy works best with. One of the things you get that is really handy having your application packages as NuGet packages is that you get versioning out of the box, some metadata out of the box as well, and it's a lot easier to find out what needs to go where. You want to roll back, okay, which one is the right package? Well, with that, you know. And then eventually, Octopus deploys to AWS. So you might be wondering why we are using something like Octopus deploy instead of using a build server. After all, we're using Atlas and Bamboo. It has some features for deployment, so why not that? Well, it's going to sound a little obvious, but both those systems have different focus. And yes, for sure, you can do your deployment and basically script everything yourself and run it from your build servers, just as much as you could run your builds from a deployment tool if you wanted to by just running a script. But really, that's not what it's about. You're going to be fighting the tools all the time. So why not? Another difference as well is that with a build server, everything's going to happen on the build agents, right? The build agents, that's not where your code's going to run. So eventually, you're going to have to open a lot of backdoors on your, let's say, your web servers to be able to deploy your code, to make your changes to your IIS and all these kind of things. That's nasty. Again, you can do it, but to do it right is difficult. With Octopus, what we get is that everything runs on the target directly. So we've got a small backdoor opens for Octopus to actually deploy the package. But after that, everything happens on the server itself. Much better. And finally, yeah, I guess one of the points with this as well is they've got different failure modes, really. When you've got a build that fails, you want it to fail and fail fast. So you can go fix the problem and go again and move on. When it comes to deployments, though, and especially deployments to production, that's slightly different. If you've got a problem as you deploy to production in a web server, for example, what do you want to do? Do you want to stop? Well, yeah, what state is the server in? Do you know? Is that going to cause a problem if we go again? So using a system like Octopus, we can have guided failures or manual interventions so that we can go and check out and make sure that everything is OK before actually going ahead again. Now, enough about Octopus. If you want to hear more about this, there is a talk tomorrow morning at 9 by Damien Brady. Damien, say hi. So at 9 o'clock in room 3, he knows a thing or two about Octopus, being one of the solution architects there. So yeah, that should be great. That's done. So now, obviously, we know how we're going to do the deployments, so we need to worry about infrastructure.
Oh, that's right.
How does that work?
We need to put our code somewhere, don't we?
Yeah.
Right, okay, so our general tool chain, SQL Server and Elasticsearch are two major data stores. Obviously, they run on Windows and Ubuntu. We use PowerShell on the Windows side for all our automation, Python on the Linux side. I don't really understand that. And we push that out to AWS, and we orchestrate all our AWS resources with CloudFormation. If you don't know what CloudFormation is, it's a JSON-based object description format, I guess. You can basically package up all of your, you can package up all of your AWS resources together in this JSON document and deploy them as a unit. So you can speed things up quite nicely there. And that's that for that slide.
Yeah, so let's have a look in more details at what things were like as we started. So we got a little bit further. Along the way, as we started to do that, we were, we had a few cultural changes. The team was growing significantly. Initially, like 3 years ago, so not that long ago, we had only 7 developers in the team, and that was it. We also decided to try to become a little bit more independent. So in case you don't know, the domain group is actually part of a bigger group, which is Fairfax Media. So we used to share everything with them. We used to share an ops team, we used to share QA, design, UX, mobile, you name it, we were sharing it. So just to be able to move a little bit faster, we decided to bring everything back in-house. So yeah, that's the additional challenge, right? Because we need to find the right people, we need to make sure that they've got the right culture, they understand what we're trying to do, and that's it. At the same time, we thought, well, it is time. We need to go and adopt Agile. But yeah, we were sort of kind of doing Scrum before, but this time we're really going to do it. By the way, this image has nothing to do with Agile. I don't know what it's doing here. So you might have heard of things like, yeah, we're doing Scrum, but we're not doing this, or Scrum, but we're not doing that, or things like Fragile. We decided that this time we do it right, we follow Agile, or Scrum specifically, to the letter. And it actually worked out well. As Jason said as well, we also decided that, okay, it is time to move out of the data center, embrace the cloud. It's looking good, isn't it? So we knew that doing all this, we would be building a lot more applications, that we want to experiment a lot more, and that's something that it's always difficult to do with your own data center, obviously, unless you've got lots of money to spend on it. So we had to do some architectural changes. Let me just show you what domain was like before we started this. Look at what we've built. It's awesome. It works well, but every time you change this little bit, you don't know, but that other bit over there is actually moving, and you've got impacts on everything. So putting more people on the team and touching the code, it got really, really challenging at some point, and we had to do something. Really, it's all about reducing the dependencies on other people, other teams, and other systems at the same time. We needed to find a way to fix this. So just in order to have the higher velocity, really. So the way we fix this, first is to split our big 25 developer team into smaller teams, so each responsible for a slice of domain. So for example, you would have a team responsible for the search experience for all our customers, another one for the user customization, another one for, let's say, agent products, and finally one to look after the platform and all those tools that we're talking about today. And so yeah, each team was, in theory, meant to be completely independent, except that when we all collaborate on the same code base, that doesn't work. So then we moved on to the next step, which is re-architecting and moving to microservices. So microservices, if you're not really aware of what that is, that's basically service-oriented architecture meets domain-driven design. Or in other words, everything we build is an API, and it has only one reason to exist. So that way, it means that each team can own a bunch of services. They can deploy it whenever they like. It doesn't matter. They don't have to coordinate with anyone because they're the only owner of it. And everyone is much, much happier. The last enabler for this is feature toggles. So that might sound a little bit irrelevant here, but it's actually very, very important. So feature toggles, really what they are is the ability to turn features on and off on the website or any of our applications at any time without stopping or redeploying the application. So why is that important? Well, because we can then deploy much smaller changes and just hide them behind a feature flag, even if the code is not 100% finished, or maybe we're waiting on another team for something, right? Maybe all the backend code is done, but we're waiting for the UI. Or with the microservices, maybe the UI is done, the website is ready, but we still have a couple of bugs to fix in the services. So that way, the front-end team doesn't have to wait for us. They can go and deploy their stuff, move on. Their code is not inventory anymore. And then when we're ready, when the microservice is there, then they can just flick it on, and that's it. So the way we've built this, and that's our feature flagging dashboard. So sorry, I had to hide what the features actually are. But it's just as simple as that, really. A list of features, a status on and off, and that's it. When we turn it on, we just have very, very simple rules. So we can decide to enable a feature for, let's say, 10 or 20% of our customers. Or we can decide to turn it on only for internal staff. So yeah, testing on production in a way. And that sounds scary, but it's actually very, very efficient. Well, you need to do some other testing first, or don't just push your code into production. So yeah, that's very simple. You can build one. It takes literally just a few days. It's very simple. And we might eventually open source this code. So to summarize, much smaller teams, microservices, and feature toggles. For us, that means high velocity. And that's how we got to that chart you saw earlier. But if we're going to go down that route and start building a lot of microservices, well, we probably had to standardize the approach. Because, yeah, otherwise it's really hard to maintain and really hard for people to jump from one team to the other. So this is what we set out to do. And we set out to do that at the very beginning for our very first service. It was very important to get it right. So it doesn't look like much. Yeah, okay, so we're calling our API on the ping endpoint, and it's returning pong. Big deal, right? Well, it turns out that it is important for our load balancers to know if the application is running or not. We don't care if it's working or not at this point. We just want to know that it's running. So that means that for our load balancers, if they find that this is returning 200 or not returning pong for some reason, that box would just disappear and get replaced. So that's all good. That's one thing covered. Next, we've got the health endpoint, which comes in standard. So what that does, it helps us find out if a service is healthy. Now, when I say service, I don't mean just the API, but just a service in a broader sense of the term. So even if you've got like backend services or things like that. So in this case here, we're looking at our email service. So it's using a few queues on AWS. That's where our messages go first before they get sent. But what if the background processor that's actually sending the emails is not working, right? The API is still up. Well, no, with this, it's not. So we're monitoring the number of messages in the queue from the web service directly. So that means that then from external monitoring, we know if anything in a service, again, the big service, is working or not just the API. And so yeah, that's a quick way of monitoring background processes, and that's been really, really effective so far. We've done that before, yep. The next endpoint we've got in standard is for the documentation. So we're using something called Swagger. Most of you probably have heard of it. So it's a very popular standard at this point to describe web services, or at least for us, we're using it for that. The good thing with this is that it means your documentation is then extracted from your code as opposed to coming from a wiki. So it has, yeah, a much better chance of being up to date, right? Because, well, it is your code after all. So what does that look like? This is rather long, but you get definition of every endpoint in your web service, what the request parameters are, what you're going to get as a response, and also the response that you should expect. Of course, there is a people version of this. So if you want to know how to use an API or something, you can just go in standard to this endpoint, so Swagger UI index, and that gives us the full documentation of a service. Now, obviously, it's not just a list of services. We've got the details here, for example, of the response class, but we've got the parameters that it takes for the request over there. That's really cool. All that in standard. And then for most of our services, but not all at this point, most of the most recent ones, we're using a framework called metrics.net. That's a project available on GitHub and NuGet. So what that does is just something you plug into your application, and it's going to constantly monitor the calls made to your service. So what's really cool with this is that you can see how often the service is called, or how fast it is, or it gives you really, really detailed stats. So you know, yeah, most of the time it's responding that quickly, but for a few calls it's that slow. So yeah, that's always good to know. And we can also ship that to a different system later on, obviously. So yeah, again, it's rather long, but we get details for every single endpoint, and yeah, that has helped us quite a few times. Cool, so we know what we're going to be building now. How are we going to build that, and making sure that everyone follows this, because there's quite a bit in there. Well, we started by building a Visual Studio template for those projects. Again, that's something that we did as part of the very first project. So once we had our first service ready, we thought, yeah, okay, lock it in. That's what we're going to go with. So yeah, we've seen a few iterations of this now, but basically what that's going to do, it's going to wire up everything by default so that every team, well, each team, when they start building a new service, they're going to get all this. They're going to get ping, health, docs, and metrics. We also hooked up our OAuth server automatically to this, so in theory, we secure by default. In theory, with security. So that's cool. We've got our code now. Our application is running on our dev machines. What do we do after? Well, we need to build it. So we designed a brand new continuous integration pipeline at this point, and the goals were to be able to run our test, obviously, but also to generate test coverage reports at that point. We want to know what's missing, when we need to plug the gaps, and all that. Package our applications. Well, yeah, we want to deploy them. Run local builds, because I don't know if you've had to do that before, but have you had the case where your build is not running on the build server? You have to figure out what's going on. You make a change, hoping that it's going to fix it. Commit again, and damn, you're in the queue. Another 30 minutes before you can actually see if anything works. So yeah, obviously that's no good for troubleshooting, so we wanted to be able to run our builds locally. Just one PowerShell script, off we go. And also, I don't want to have everyone in the team, so yeah, the 25 days we were talking about before, installing all the tools that they need to run a build, and which version of this do I need, and maybe for this project I need that. So we really wanted it to be self-contained, and we use NuGet for that. So yeah, it also needed to be reusable, because obviously if you build one microservice, another 10 pop up. So yeah, it's important to be able to reuse those scripts everywhere. So what do we have in our build toolchain then? So we're using a project called Saki for build orchestration instead of MS Build. So Saki is a PowerShell framework, really. You got the same concepts as with MS Build. So you get targets, you get things that you can chain, and the advantage though is that you've got the full power of the .NET framework behind it. It's actually usable, not like the MS Build scripts, which are, well, all XML really. So to avoid the angle bracket tax, really, we use PowerShell for this now. We still do use MS Build behind the scenes to actually build, do the base build of the applications, but then all the packaging, testing and all that is done with PowerShell. We do support NUnit, XUnit, and MS Test out of the box because, yes, different teams have different preferences of one framework or another, so we just want to make sure that everyone can use what they want. We don't want to be too prescriptive here. Okay, we've got our test. For the test coverage, we're using OpenCover, which is pretty much the only remaining test coverage framework, I think, at this point for .NET. And we generate test reports, HTML test report with report generator, which means that then, once our tests run and once the build is finished, we can go and see the details of which test passed, which one didn't, directly from our build tool. And yeah, obviously, yeah, we package at the end, so NuGet packages or zip files. So there is a lot in there. The good news is, if you want to follow the same kind of principles, you don't actually have to rebuild all of it. As of lunchtime today, this is open source. So if you go to github.com/domain-group/OSS/domain build, we've got a fresh new project there. It's also on NuGet.org. Well, will be in the next hour or so, or after this. So yeah, that's pretty cool. And if you want to see how we actually put this together, shameless plug here. I've got a Pluralsight side course on this, continuous integration with Saki and TeamCity, getting started, if you're interested in knowing how we've put this together. Cool, so we've got our code, we've got our packages. Now, how do we deploy?
That's a good question. How do we deploy? I think we've already mentioned we use Octopus deploy. Good, right. Yes, we do. We defined a generic sort of template deployment plan within Octopus deploy. This screenshot is ever so slightly out of date. Sorry about that. But you can see what we do is, in the middle, we actually do the meat of our deployment. We set up a few prerequisites first. So things like IIS URL rewrite, if your application needs that. various other sort of IIS prerequisites, things like this. Once we've done the deploy, we then set our app pool timeouts and maybe do some stuff with the security around our new app pool user. And then the actual deployment is not here. It's down here in the IIS multi-tenant hot swap. This is worth going into a little bit more depth. Okay, so when we deploy in the deployment step, unlike just going immediately live, we deploy next to the current live application. These are two separate IIS websites. The new website will have a dummy binding, so it won't actually be serving on, let's say, email-api.domain.com.au. It'll be on release-email. Anyway, nobody can get to it at this point. It's kind of hidden away behind the scenes. When we're ready, we've done all our prerequisites, and if necessary, a little warm-up. We take the binding in IIS and swap it from the live application to the new application. Now, this is a little bit like while you're driving along in a manual car, just crunching the gears without using the clutch. It'll work if you time it just right. If you're revving pretty hard, then you hear a crunching noise. So occasionally we modify this a little and we'll pull the boxes out of the load balancers before we do the swap, but that's only really for the very high load applications.
And it's fully automated as well.
And it's fully entirely automated.
It just takes longer.
It does take a little longer. Once we've actually done that crunch, we let the connections drain off the old application, so all of the in-flight connections, they're dealt with, and we remove the old site, and profit. The box is back to how it was before. It's just got the new version running, and we're done.
Cool. So yeah, now that we've got all the pieces in place, how does it work for our devs, right? They have to remember how everything fits together. That's a little bit complicated. Well, it's not. So we've got for them three default branches that they've got in every repository: develop, release, and master. So typically, developers would work on the develop branch, commit, 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 happy, happy, and that would deploy automatically to UAT. So yeah, we got a hook on Git that would trigger the build, and the build would trigger the deployment. That's it. Once they're happy with it, they would merge to release. And the release branch would trigger an automatic deployment to staging when we got commits. So that's really cool. Staging at this point is, yeah, I guess we can say identical to production anyway, just slightly smaller.
Yeah.
So that's not a problem. We're fairly sure that if it works there, it's going to work on production. You might have a couple of fixes to do, a couple of changes, and once you're happy, merge to the master branch. And when we merge to master, you guessed it, we deploy to production. So that's pretty cool. It's all automated. It means that for our devs, that's Git-driven deployments, really, and that's the dream, isn't it? So yeah. So how does it work from, how do they define the infrastructure then, Jason?
Oh yeah, well we've done all this magic with our code. We need to put it somewhere. So as with the build plan, we wanted to have a nice generic standards-based sort of target. So we standardized a simple Windows cluster. In AWS, we defined a VPC. If you're not an AWS user, VPC is virtual private cloud. It's your network boundary, let's say. We have a VPC for production, a VPC for staging, VPC for each of our environments. Within there, we've got two availability zones, which is, if you're not an AWS user, that's like having two separate data centers, let's say. If one goes, the other one is usually fine. Usually. A month or so ago, I would have said it's perfect, but yeah. Within there, we put public subnets. This is where our load balancers live. Sometimes we have instances in there, but these are the bits that are accessible from the internet. We've got private subnets. Usually our servers will be running there. That's out of the way. Nobody can contact it. Some of our ops guys can contact it directly over the Direct Connect, but yeah, let's not talk about that. We put a HA load balancer into the public subnets. This is just an ELB, an elastic load balancer. All cloud services have load balancers. And then our instances live behind that. And this is all standardized as a CloudFormation template and will support, pretty much all of our simple workloads. On top of that, we make sure SSL is available by default. We put a wildcard certificate onto the load balancers so that star.domain.com.au is available over SSL. We'll put IIS onto the instances using PowerShell. Obviously, we're mostly serving web apps, so we need a web server. We chuck a few supporting tools on there because we need to be able to troubleshoot them when they've gone wrong. So sysinternals will live on there, things like that.
And the Octopus tentacle as well, anyway.
The Octopus tentacle is a supporting tool. Very good insight there, Mr. Ruffin. Thank you. and this is a fine baseline config for most of our workloads. And what we'll do with variations on that, if we've got an application that needs, let's say, again, URL rewrite, we'll push that through Octopus. So Octopus is our engine of variation, if you like. So what we realized we were building was a robot army. These individual robots are self-provisioning, they are self-healing, they're expendable, they are generic, cheap, simple, and they're robots, not people. You've heard cattle, not pets. Some of the people in this room have got it on the back of their t-shirts. We don't think of them as cattle, we think of them as robots. They're not people, we don't name them, we don't love them. If one of them goes away, it just comes back. This is a robot army that will take you down.
That's it. What is important here is that really we don't do Snowflake server as well, the one-of-a-kind kind of server, handcrafted. It's really just Phoenix servers now. So if the server's sick, shoot it, another one's going to come back.
So the Phoenixes now, as well as robots?
That's right.
This is a mythological mess. In terms of provisioning these actual clusters, this is probably the third time I've mentioned this, but CloudFormation is what we use to orchestrate all our AWS resources together. And we'll drive the instance configuration itself out of PowerShell. We'll use DSC for that, which is desired state configuration. If you're not familiar with that, it's the, how do you pronounce idempotent? Is it idempotent or idempotent? That thing. You can run it over and over and over and you get the same result. It's a declarative, make it so kind of a framework. And we push out the application code and the variables as we keep repeating with Octopus deploy. Now, once this is all up, we need to make sure it stays up, and we need to make sure we know when it falls over, because it never falls over, right? We're perfect. We use Pingdom for the external monitoring of the health endpoint that Fabien mentioned earlier on. That'll hit the health endpoint. If something's not healthy, you get a 500 Pingdom goes, ah! We use New Relic to monitor our performance. That's New Relic down there. We use CloudWatch, the AWS service up in the top right, to monitor the state of our AWS services. They all tie together through Opsgenie, which calls us up in the middle of the night sometimes, not very often because we're great. And all of these messages go into Slack, which is our primary communication tool within the team. We get messages about Robot Army boxes coming up, Robot Army boxes going down, load balancer status changes, Pingdom, anything that can tell us something interesting, we'll pipe it into Slack. Over to Fabien.
Cool. So yeah, that's pretty much the picture of our first few iterations and how things worked at the time. So that was great. Good start. The problem is that we kept growing the team, and I think we're just over 100 people in the tech team now, going from 7 to 100 over just a couple of years. So yes, some of those processes that we just talked about didn't actually quite work. So let's just go and have a look at where we are now, the next step. Sorry. Had to. So yeah, so we thought, well, hang on, we've got more people, we've got more teams. How are they going to know about all this from day one when they start, right? Ideally, we should be in a position where a new starter in the team, get their laptop, open it, oh yeah, I know, I just need to do this, and then by the end of the day, they've got a new microservice running in production. Again, true story, we actually have one guy doing that just a few weeks ago. So we thought, well, hang on, what we need is Project Sauron. And one script to rule them all. So if you remember the Visual Studio template we talked about earlier, so yeah, we thought, let's push it a little bit further. What if, as you create a new project, you would talk to an API and create the new Bitbucket repository? What if, well, we're at it, would create the 3 branches we always use? And yeah, create the new microservice solution, as it already does. Let's just push it a bit further, maybe. Create the Bamboo build plan. Now that's a mistake. If you've ever tried to automate Bamboo, well, you probably know that it's impossible. We had to use Selenium behind an API to do that. It's disgusting. I just have to mention, we actually got it working. The code is there. Just put a nice API on top. And you're going to be all right? You want some water? All right, so then at the same time, what about triggering the provisioning of infrastructure at the time the first build happens, right? Or the first deployment. And while we're at it, I mean, we've gone so far already. Why not registering with the monitoring platform? So ping them, New Relic, and all that. We did it. Yeah, it's working. Huge mistake, though. So that's one of our bad ideas. That was actually, we were serious about this at first, weren't we?
Oh, yeah.
We wanted to do this, but we've got a few less serious projects to show you after if we've got time. So yeah, we've basically pushed it too far. So at that point, what happens? Well, because it's all automated, everyone stops worrying about how things actually work. And as you know, being here, it's really important to know your tools, right? Well, not everyone thinks that way, and we start having issues. Then what about, I'm going to create a new project, domain, D-O-M-I-A-N. No, it's the other way around. Well, it doesn't matter, I've got a new microcluster running. So yeah, it's not ideal. So we thought, well, okay, let's pull it back. A few valuable lessons here, though. We've learned that, yeah, Bamboo is good, but for an automation tool, not having APIs is just not acceptable. Or at least, by the way, disclaimer, that was about a year and a half ago, maybe things have changed. So we just decided to swap it out, and Bitbucket was just collateral damage at this point. And we replaced with GitHub and TeamCity. GitHub, that was for a different reason. We wanted to use the pull request stuff that works, a little bit better at the time in GitHub than Bitbucket. So anyway, TeamCity, when we started using it, we realized, oh, well, hang on, actually, that works really, really well for .NET projects. So we stuck with it, and to this day, that's still what we're using. We also had to make some changes to the branching strategy. So a few of you might have thought, well, hang on, you're deploying automatically to production. That's madness. Yeah, it is. So what happened a couple of times, not very often, is that someone thinks they're on develop, but they're not. They're on master. They make a quick change, like, I don't know, make domain red, like our competitors, for example. Push that as a joke, right? Yeah, but that's a joke that just went to production. So we can't do that anymore. So what we're trying to, well, that was not that bad. So what the devs do now, they've got feature branches, just as many as they want, dev. Once they're happy, merge the branch to the release branch, which we still have. At that point, yes, it still deploys automatically to staging, because that's something that we do often, and let's not try not to be too repetitive. But that stops here. Then if they want to push it to production, they have to do it manually. When I say manually, it's actually not that bad. We're using an Octopus feature called Lifecycle policy, which means that we can force our devs to have their code deployed at least to one of our testing environments before going to production. They may just go through it and not even test the application, but our monitoring will tell you that something's not working at this point. So yeah, we deploy to production, now things are safe, and you've got your sanity again. Or
have I?
Quite. So that's cool, but yeah, we made also some changes to make sure that the devs, because we had to scrap Project Sauron, to make sure that the devs could provision their infrastructure relatively easily. And that's what Jason's going to talk about now.
Oh yeah, this is my favorite bit. So we wanted to empower the developers to do ops. Why? Because, as I mentioned earlier on, ops guys are really lazy. This is how we used to do the cluster definition back in Robot Army version 1. It's horrible, isn't it? You needed an ops guy that kind of understood the PowerShell, kind of understood the CloudFormation, understood all these things. Every individual cluster, so let's say our email service cluster, had its own CloudFormation template, and it had its own set of provisioning scripts, and it had its own cluster deploy script that would talk to Octopus. And to build a new one, you had to copy all of these, change some things, mess around in the CloudFormation, which was 900 and something lines of JSON, which is not really human readable, let's face it. Ew, horrible. So what we needed was a sort of a domain-specific language. Hey, we're called domain. That's good, isn't it? A domain-specific language that our developers could use to define the infrastructure that they needed. Now, turns out we were already using this within Robot Army, just on the instances. We leveraged the DSC engine within PowerShell, which gave us a nice clean declaration like this for our clusters. So a developer could go build one of these off a very simple little template, tweak a few things, go happily, I will deploy the example service, which isn't in production, let's face it, and they could put that in their build. Then, when it came to the Octopus deploy stage, we could deploy the Robot Army bit of the package, onto a role called the PS engine, and we could run the configuration, and AWS would stand up all the infrastructure.
So this is still in the application deployment process, right?
This is still in the application deployment process. Down here is a normal application deploy for this, in this case, the statistics web API, which I probably should have blurred out. So, well, this is great, right? We're deploying, but surely we're deploying to infrastructure that doesn't exist yet. This is magical bootstrapping nonsense, right? But it's okay, because we're deploying to the PS engine role and those boxes exist, this deployment will complete successfully. And you get a lovely little green tick in Octopus saying, oh, look, version 0.01 is live and everything's happy. Then 10 minutes later, when the boxes actually come up in AWS, a script calls out to Octopus and says, hey, Octopus, I'm new. What code do I need? Octopus says, oh, look, version 0.0.1 is available, pushes it out to the boxes. So in one touch, you've got your infrastructure with your code on it. It's quite nifty, quite like that. It's good. That is my favorite bit. Okay, so also at this time, we saw some gaps in our infrastructure. We thought, oh, look at us, we've got magical nonsense going on. We're unicorns, we're sparkly. We weren't really. Octopus was on one single box, and we were relying on it for all our autoscale events. So if load increased on domain, and we had to add more boxes, we had to call out to a single, not very high availability Octopus deploy server to do our deploys. So these heroes over here, and that hero there, came up with a high availability version of Octopus and said, hey guys, do you want to try it out? Yes, do we ever. You'll recognize this from earlier. This is the Robot Army sort of network diagram, if you like. We just plugged in some Octopus on the back. That automatically provisions itself. It knows what parameters it needs. It knows its license keys and all that kind of stuff, because we've got that infrastructure as code. And that means we've got a lovely open-sourced Octopus server DSC resource that you can use to build your own Octopus servers in moments. It's quite good. And just for good measure, because we don't know when to stop, we put an Octopus in our Octopus so we could Octopus while we Octopused. Meaning anytime I want to upgrade the Octopus cluster or change the size of it or do anything like that, I just do a commit in Git. The hook goes to my hook server. The hook server goes to Octopus. Octopus deploys the code, and we've got a new Octopus in our Octopus so we can Octopus while we Octopus. Thank you. At this point as well, we realized that testing was really hard. Ops guys, we're lazy. We don't like to go, oh, is this server up, and go and log into AWS and check that all the servers are there and things like that. So infrastructure is code. Why not test it like it's code? There's a testing framework for PowerShell called Pester. Catchy name, right? We plugged that into all of our Robot Army stuff. It tests the code that runs the Robot Army. It tests the configurations of the Robot Army that the developers write. It tests whether the servers are actually there when they're meant to be there, all these kind of things. So we're doing infrastructure as code like developers do code, right? This is good. This is fantastic. It does all get very, very expensive. This is the terribly boring bit, so I'm going to skim through it quickly. To save costs, we turn off all our idle instances overnight. You can do this when you're in the cloud. You know this. You all know this. You're smart people. The dev environment, devs don't need it after 7:30. We turn it off. Devs don't need it before 7:30. Actually, devs don't need it before about 10, really. So we turn it off anyway at 7:30 because 12 hours is a nice round number. That's fantastic. We do it in AWS with tags. In other cloud servers like Azure or Google Compute or whatever, you might do it a different way. But we'll tag sleepy time equals yes. All of those instances go away. There's a second advantage to this in that when the instances come up in the morning, we're testing our deployment process straight away at scale. Every bit of our environment gets tested every morning when sleepy time works. The second cost-saving strategy we put in place was to maximize our utilization. A microservices purist will say that you have to isolate your environments, and your microservice should be a single unit, and you should have hosting on its own. Oh, brilliant, yeah. It's really expensive. We've got 60-something microservices. 60-something clusters is a really, really costly thing to do. So we crammed some of them together. We changed our Robot Army definition, and we've got an array there. Now you can put as many services in there as you want. They will deploy in parallel, kind of. So we save a lot of money on our staging environments with that. And what was the third one? The third one is, oh yes, price optimization. Pick the right size of infrastructure. Don't use C4 X larges for a tiny microservice that does 10 requests a day. And all of your cloud services will allow you to reserve capacity up front. In AWS, it's called reservations. What's it called in other services? Don't know. Upfront reservations. And there's a thing called the spot market, which is probably worth quickly calling out. AWS auction off their excess capacity at really, really cheap prices. If you want cheap servers, you can get them for sort of 10% the price. So look into Spot if you're on AWS. Over to you again.
So that brings us back home. This joke, sorry about that, that's from our CTO. He insisted we put it in. Mark, if you're watching. So we're going to get in trouble for that one. So yeah, just if I wanted to go with just a few things, yes, it's going to take time. Yes, it's going to be hard, but it's all worth it. Like if you remember what we had at the very beginning of this talk, this one application, and that was just an example, that took over a day to deploy. Think of the time we've wasted, or we could have wasted over the last 3 years if we had to do that all the time. Or just having people that are just scared of deploying it, or just a little bit lazy. And and that's all right. The next change, someone can deploy it for me. Yeah, so it doesn't mean, it means that way we're not shipping value to our customers fast enough. So yeah, invest in this, it's worth it. When you look at, again, that graph at the very beginning, how quickly we can deploy changes to production, it has changed everything. So yeah, have a go. So let's have a look quickly at where we're at right now. So as of Monday, I think this snapshot was.
Yep.
So we're up to 34 different websites, 64 microservices, 133 offline services, averaging at 64 deployments per week for the
production.
For the last 6 months. Yeah, staging is a lot more, obviously. 620 servers, including testing and prod. So yeah, we've got Octopus to manage all that. Guess how many people we've got looking after this? Just this guy.
It's a huge team, right? Massive team. It's got to be 620 servers.
So we've got 2 Windows engineers, 3 Linux engineers. Funny that, no comments. And 2 DBAs. So what are our next steps, Jason? What are we looking at for next?
What are we looking at? We're looking at lots of magic. Currently, our Linux stuff uses a different pipeline to our Windows stuff, and we'd like to unify those two because keyword generic. We want lovely generic standardized plans. Octopus now supports Linux, so we're going to try and convince the guys to put some of their stuff in Octopus. What's next? Yes, serverless. You're going to hear a lot about this if you're not bored with it already. I got bored with it before it even arrived. Lambda in AWS or Azure Functions, there's a lot of scope for massive scalability at very low cost and all those lovely things. Docker. When Windows Server 2016 drops, we're hoping to start using Docker on that platform for cross-platform containerization. And yes, I'm going to open source Robot Army version 4. Wish me luck. V3 is not actually ready for open source. It works really well, but I'm slowly unpicking all of the bits, and I was hoping to have it ready for today. Sorry, guys.
It's a domain-specific language.
It's a domain-specific language. You can't have it yet. But soon, maybe within the next month or so, I'm going to open source Robot Army V4, and I will announce that in a mains, which Fabien will explain to you now.
Yeah, so if you want to hear more about what we've done, we've got a tech blog. I think that's what you're referring to.
That's what I was referring to.
Cool. So we like to blog about what we're doing and what we think is cool. Have a look, check it out. It's not just OPSI and backend stuff. We do have the mobile guys and the product guys contributing to this as well.
But obviously the ops bit's the best bit.
So, as mentioned here, we've got a couple of open source projects as well. We mentioned, again, just the ops parts, but we've got mobile projects as well. Android team and iOS teams have been really, I've been pushing quite a few projects over there. Another shameless plug, we are hiring across all disciplines. If you're looking for a job or if you want to change, come and see us. We're at the booth upstairs. And that's it.
Follow us on Twitter.
Follow us on Twitter.
Yes.
I almost missed this.
Oh, that one.
You want to?
Oh yeah, I'm doing a thing in Singapore. That's Singapore, isn't it? I'm quite tired. 21st, 22nd of October, I'm appearing at PowerShell.asia, which is the PowerShell-oriented magical thing for local PowerShell developers, because there are some of us. Come along. If you do Opsy stuff, or if you're interested in automating in any kind of sensible way, come along. It's a whole day in Singapore. It's very fun.
Cool. So yeah, we still have a couple of minutes, 5 minutes actually. Who wants to see the stupid IDs? Yes. Yep. Yes? All right. So those ones, they were not, well actually this first one was a serious one. The domain train. So we thought, as we're starting this new process of deploying new things, well usually we just screw it on the roof. Yeah, we're deploying the new domain desktop site. Watch out, brakes. Now we thought, well, if we automate everything, well, we have to let people know, right? So that's what happens at the beginning of, well, what happened at the beginning of every deployment.
All aboard. Deployment in progress for release 1.0.9 of email service in staging.
And here we go. It's fun, right? It's not noisy at all. It's perfect. Yeah. The thing is, as we started ramping up our deployments, that got annoying really quickly, as you've heard. This one was for staging. I mean, okay, production, let me know, but staging, really? Do we have to go there? Well, probably don't. So yeah, the train is in the box now. The next project, you want to talk about it?
Sure, I'll talk about the next project.
I don't want to take any responsibility for that one.
I'll take responsibility for this. This is fine. Every couple of months we do a thing called Innovation Day. We call it Innovation Day. Some people call it Hack Day. Some they call it whatever. A day to do stuff. We decided that our developers weren't really committed enough to the deployment process. They weren't really getting a hold of it. So we took an Xbox Kinect and we stuck it over here, and we took a screen and we stuck it over here, and we got our developers to walk up to the Kinect and in a loud, clear voice say, "Hey, deploy email service to production, please." And the screen would say, "Dance, monkey, dance."
Oh. And that's the monkey.
As you can see in the background, our machine is analyzing his excellent dance movements and looking for specific movements. We looked for things like a clap, or a hip thrust, or a bit of an arm wave. And we looked for all of these things. And when the system decided that you'd done enough, it would actually deploy. So Octopus Deploy would deploy what you asked for. Not only that, if your deployment failed, we're videotaping this whole thing in 1080p. And if it fails, it goes on Slack, and everybody sees you dancing. This, my friends, is my finest hour. Thank you very much.
So yeah, so that's all we've got for today. I guess, do we still have time for a couple of questions, or? Sure.
Questions? All right.
Anyone? Yep.
So you said Project Sauron was a step too far. Does that mean for 158 services or whatever, each Octopus process and Team City process has to be wired up step by step manually?
No, so we do have templates for most things. So yeah, the question was, now that we've scraped Sauron, does that mean that we have to create everything manually? So yeah, in Team City we've got step templates for everything. So yeah, so for the main build, I guess, which does everything that is required, but also to if we want to run integration tests and all that. So we've got, depending on the application we're building, we can have different, slightly different processes, but the core steps are fully templated. It's super easy to use.
Yeah, we've gone from one click to 5 different one clicks, which isn't really a big deal, we don't think. Nah.
On the deployment side, then for Octopus, there is no such thing as a template in Octopus. Come on, guys. So what we do usually is that we clone one of our well-known projects that we already have for each team, make the few adjustments that we need to make, and that's it. So it doesn't really take pretty long. And then on the upside, as you've seen, that's just this little snippet of PowerShell. Push it in your solution, and that's it.
You don't need Selenium for it, though.
And you don't need Selenium for it.
Although now you mention it, should we just plug Selenium in anyway?
Nope.
No, wait.
So I saw when you were talking about your density on your servers within CloudFormation, you moved from a single declaration for your service to an array.
Yep.
Had you thought about pushing that to a scheduler or pushing that out to some other means to manage that? Because how do you leave that up to a developer to choose that?
Pretty much.
Oh,
Yeah. We trust our guys. They're all really smart people, aren't they?
Yeah, well, the
You
thing is,
hired them.
So the thing is that we try to make sure that every team is responsible for all of their apps. Obviously, given the number of apps, we can't just say, hey, chuck it over the fence, apps problem now. It's everyone has to really to really be responsible, right? So yeah, and who knows better the applications than the people who have written them, right? So they know what the load profile is for each of their apps, what can or cannot live together, what is really critical and really should be on its own. So yeah.
Yeah, and we don't generally tenant across teams. So one team, let's say our trade services team, will have a cluster for their staging, and they'll have 4 or 5 different projects running on that cluster, and they know what they all are. They don't have to rely on another team's goodwill for that. So we'll kind of silo the infrastructure by team in staging. In production, the ops guys are kind of managing it, so we've got an eye on the load profiles and things like that, and we move them around a lot. We'll move the cheese of the developers quite often, sometimes just for fun. But yeah, we handle the production sort of load, but staging, go for it, guys, you know? Yeah.
The prod stuff's still done by checking in new DSC things into source control.
Yep, all of the Robot Army definitions for production are in GitHub. We've got a file that we just call it production.ps1. It's got all of our main production stuff, all the stuff that isn't in the Octopus thing that I showed. And for staging, I'll commit that and it will deploy on commit. For production, I will commit that and I will double check that I did it all right, and then I'll deploy it from Octopus.
Yeah. Oops, sorry.
Sorry.
Oh, yeah, good.
You go. Okay. In your branching strategy, you've got developers on feature branches of release,
Yes.
and then once the release changes have been pushed to a staging environment and verified,
Yeah.
and then change get pushed into main.
Mm-hmm.
Why did you take that approach rather than just straight working off main?
Well, that's pretty much what we've got now. So in that last diagram, hang on, let me just bring it back up. Oh, that's going to be ages.
It's going to be a long
That's yeah. Hang on. So what we've got now really is we've got only 2 main branches. Well, one main branch, so which we call release to confuse everyone. So that one really that's our staging and production branch at the same time. I mean, if the code is good enough, why should we need to merge again somewhere else? That's something that we've learned as well from our time with the 3 branches, that it was probably a little bit unnecessary. Yeah, there it is over here. So yeah, that's what we're left with now. So for this, yes, we might have a few at a time because we might have a few different features being worked on at the same time. But there's only one of those, and this one never ends.
You promote a build rather than a code. Right?
Yes. Yeah. So actually, yeah, that's another thing as well. With the old way, every time you want to deploy to another environment, you had to wait for a build again. So those builds were quick. That's usually about 2-3 minutes, which is reasonable, especially for the microservices. But yeah, really, do we really need to do that? We know that the code's good. Why not just ship it to prod, right?
Yeah, it's the same NuGet package that goes to staging and prod once it's tested.
It wasn't the case before, it is now.
Yeah.
Who else? Yep.
What are you using for your NuGet server? You say TeamCity, how are you finding that?
We're not using TeamCity for a few different reasons. First, we found out that, well, this is our IP, right? This is important. We can't just push it on the public NuGet gallery. I guess you know that. But so then we had the option of using things like MyGet, which is public hosted, it's all good. And we can have private feeds. But the thing is, for the volume that we had, like the desktop side, the domain desktop side is actually quite heavy. As soon as you get to a few builds, that gets really, really expensive really, really quick. What we wanted to do as well is have a feed per team for their applications, and then one feed for our internal NuGet packages as well, like class libraries, really. So what we ended up doing is building our own. So based off the NuGet.server, I think, package, and then just stuck on a UI on it, and that was it. We thought of pushing that open source, but it's actually taking quite some time to maintain. Now with NuGet v3 coming up and all these kind of things, we don't necessarily have the time to maintain this properly, so we're looking at other solutions at this point. Anyone else?
Do you have any problems with app configuration? So with that change per environment, like
The transforms, Octopus takes care of it for us, and the ops guys don't really have to do anything there. The devs will manage their own variables in Octopus. We don't.
Know
We don't know, so.
where all the endpoints are in each environment.
Yep. So the cool thing with that, so initially we started by using transforms, which, yeah, that works okay, but it's really hard to, at dev time, to see, okay, what am I going to end up on production with in production? So yeah, we use Octopus now. It's got a good configuration management. The cool thing as well is like for connection strings or things like that, you can encrypt them, and you can't get them back. So that's a good thing. Like even if let's say our DBAs create a new database for a new service, they can go and drop the connection string in there. The devs never know what it is. So if we've got someone leaving, they can't. Yeah, they don't know our passwords. They don't know anything, which is a good thing.
So I mean, we'll put API keys in there as hidden variables and stuff like that. And the dev, an ops guy will drop a variable into Octopus, and no one else knows what that API key is. What LastPass does. But yeah, it's quite good to use Octopus as that engine of variance, as we use it for the engine of variance for the configuration of the instances. So yeah.
Anything else? Cool.
Awesome.
Let's go.
Time for a drink.